participantes que se encuentran en la sala de Zoom sobre la traducción en línea. Thank you very much for attending this regional event.
I give the people who are going to support us with the translation a pass to provide information to the participants who are in the Zoom room about the online translation. Go ahead, Fiona, please.
Gracias, Germán. Thank you, Germán. I'll begin in Spanish. Hola a todos. La interpretación ya ha sido habilitada. Verán en la parte de abajo de su pantalla un botón que se llama interpretación con icono de globo. Si necesitan interpretación al español, pueden hacer clic sobre ese botón que se llama interpretación y luego seleccionar la opción español. So once again, if you need interpretation into English, you'll see a button called interpretation at the bottom of your screen. It has a globe icon, so please select that button and then select the English option. Thank you very much. Muchas gracias.
Muchas gracias por la información brindada, Fiona. Entonces,
thank you very much for the information, Fiona. And I will give you a couple of seconds so that you can configure the language you want to listen the presentation on.
You have a few seconds to configure the languages in which you want to listen to the presentation. Come in, please. Okay, bienvenidos a este evento.
Welcome everyone to this event that's being carried out today on the World Metrology Day, and the topic will be metrology in the digital era. This event is being shown in Facebook from the different institutes, and I would like to welcome people who are watching us on the social media, and we will share the link so that you can share this presentation with your colleagues. My name is Germán Romero from the National Institute of Metrology from Colombia, and I'm going to be the moderator today. This event is organized by the Inter-American System for Metrology, Cipm, with the support of the working group number 14 from PTB and the Inter-American Metrology System. Before starting, we need to take into consideration the following. One, I will confirm that this event is being transmitted on Zoom and being retransmitted through social media of different institutions from the region. So this webinar is going to be recorded in these platforms. It's important for everybody to have your cameras off and your mics off, and you can ask your questions in the chat, and when we finish the presentations, we will answer questions and take comments. Please, when you make your questions, don't forget to indicate to who you're asking the question, and in case you want to activate your audio to ask a question, please raise your hand, and the icon for this is in the bottom part of the application, of the Zoom application. For the persons who are watching us on social media, you can make your questions in the chat room of the social media network where you're watching us, and we have collaborators that will be paying attention to these questions that you might make.
To give the words of welcome and opening of this event. Dr. Claire Sondry is the president of the Inter-American Metrology System, Cipm, and also the director of International and Academic Affairs at the U.S. National Metrology Institute, NIST. She received her doctorate in biological chemistry from the University of Virginia in 1989. Dr. Claire Sondry supported the processes and development of digital transformation in the Cipm region Science East section. That is why we are very honored and grateful that you join us and give us the words of welcome to this event. Very, very welcome, Dr. Claire Sondry.
Thank you, Hernán. Hola a todos. On behalf of la Sistema Interamericano de Metrología, or Cipm, it is my great pleasure to welcome you all here today for the Cipm celebration of World Metrology Day. World Metrology Day provides a wonderful opportunity to recognize the work being done within the metrology community to advance measurement science and quality infrastructure around the world. While many of you here today represent your nation's National Metrology Institutes, or NMIs, you are also part of the CIM family, the Regional Metrology Organization for the Americas. You are all part of this collective effort to support technical cooperation and the advancement of metrology capabilities for our organization's 33 active members and 13 associate members. As is customary on World Metrology Day, a measurement topic of interest is chosen as the focus for the celebrations. This year's subject, Metrology in the Digital Era, is timely, appropriate, and increasingly critical given the significant reliance on digital technologies over the past 2 years. While we may, at times, find our digital extensions and virtual lives consuming and feel the need to disconnect, I think we sometimes take for granted just how lucky we are to have these tools available that allow us to do what we are doing right now, communicating in real time, hundreds, if not thousands of miles apart. The increasing importance of digital technologies means that National Metrology Institutes and designated institutes will be increasingly called upon to provide new and complex measurement services, which means we must think critically about how these measurement services are packaged and shared with our customers. This will be an ever-evolving challenge, but within CIM, we have many dedicated individuals and institutions working together to anticipate the needs of our stakeholders in the government, in industry, and by our fellow citizens. We, as members of organizations that strive to provide more accurate and precise measurements, have the opportunity to continue to accelerate innovation in new and emerging technologies that will transform the world. The digital technologies we rely on are made possible through key advances in measurement science. Being a metrologist is challenging, made more so every year as we stretch the traditional boundaries of what a metrology institute or designated institute is called upon to achieve. The proliferation of digital tools means that metrologists not only need to hone their knowledge and skills in specialized fields such as physics and chemistry, but also in new areas like software development and mechanical engineering. Semiconductors are a perfect example of the breathtakingly complex measurements that enable modern computing. Just a few nanometers now separate transistors on modern semiconductors. And progress in our understanding of photometry measurements have made lithography, a tool used in thin film fabrication, an essential step in the production of even more powerful computing chips. And these are just two examples of the hundreds of vital measurements that go into semiconductors. CIM is privileged to have among its members some of the world's most revered experts in these areas, and equally as important, early career metrologists who possess a fluency in digital tools that our organizations are working hard to incorporate into new and routine operations. CIM remains focused on promoting technical cooperation that equips metrologists with new skills that make their NMIs and our RMOs stronger. This is one of the reasons CIM recognized the importance of this topic and created a dedicated working group on digital transformation in 2021. I know this working group has been very active over the past nearly 2 years in helping to promote technical cooperation among CIM members in metrology for digital transformation. I applaud all of those involved in this important work and hope you all know how much we value your contributions, not only to CIM, but also to the global measurement community. I'm excited today to be part of the celebration and to learn more about the work underway in our region in these important areas. I want to thank you all for joining us for this event, and I especially want to thank today's speakers for sharing insights on the activities at their organizations in support of the digital era. Thank you.
Gracias, doctora Claire Sondry, por sus palabras de bienvenida.
Thank you, Dr. Claire Sondry, for your welcome words. And with this, we inaugurate the event for metrology in the era and the digital era. And we are celebrating the Global Day for Metrology. So right now we will start with the first block of the event. We will have 3 presentations in charge of representatives of the IML, CIM, and BPM. The first presenter is Dr. Hector Liais. He's the manager of metrology of quality and environment from INTI, Argentina. Dr. Liais is an engineer in electricity with a doctorate in Germany with the University of Brunswick, and CPM activities. He will give us the presentation of CPM activities, and it's a privilege to have his participation in this event. And we will give the floor to Dr. Liais. So welcome, Hector. Thank you for your introduction. I'm trying to share my presentation. Can you see my presentation? Thank you, Germán, for the presentation. I feel a little strange in a CIM event giving a presentation not representing CIM, but representing another organization. But as it's a pleasure for me to present the activities that we are developing and metrology in the digital era. I'm going to introduce what the Metro and Cipm convention is. And some persons might not know what these are. Everybody who works in metrology institutes, this is everybody knows this. But for a general audience, I think it's important to introduce this or present this. After this, we are going to speak about the vision of Cipm and its role for digital transformation. Then we are going to speak about the association that we need with scientific organizations and quality infrastructure. Then we are going to speak about preparations for the 27th conference of weights and measures. And then I'm going to give some indications about the activities that are going to be developed for implementing formats for the units in the digital world. The Metro Convention, for the persons who don't know, it's a diplomatic agreement that was signed more than 100 years ago with representatives of more than 17 countries, and they established a permanent structure so that the member states can act in common agreements in every topic related to metrology. Among others, they created a permanent institute that is in Paris. And its task, or one of its tasks, or the most important one, is to develop the international system for units. And in its origin, it was the metric decimal system. And its recent change, the most important one, was redefining all the units, measure units, with nature-based constants. These were the 17 original signatory countries. Now we have 63 members and 37 associates. So we have 100 countries in our continent. There's a large number of countries from CIM are a member or associate members of the Metro Convention. The Metro Convention, or the Meter Convention, is the most important bodies. Here is the General Conference on Weights and Measures, and it's the assembly where all the members attend. This year, there's going to be a general conference in November. And this general conference chooses the executive body That's the International Committee for Weights and Measures, and it's formed by 18 experts from 18 different countries, and it's the executive
la Convención del Metro tiene una
estructura
permanente que no vamos a analizar en detalle. Los dos organismos más importantes para lo que vamos a hablar hoy es la Conferencia General, la Asamblea a la cual concurren todos los países miembros, que se hace cada 4 años. Este año, como decía, va a haber una
their first activity was creating a working group for
developing
the International Digital Unit System. This was in 2019, and this group has the following terms of reference. And its objective to develop and establish a format for exchanging uniform data that's secure at a world level in networks of IoT based on the International System for Units, and it's described in the current brochure from the SI. Another one of its objectives is to coordinate this effort with all the brochure from the relevant stakeholders, establishing correct alliances. This is very important because when digital transformation is cross-cut activity with science, technology, industry, etc. It is important to make progress in this sense with alliances with all the stakeholders. And the more technical part is to propose actions, correct actions, so that the international unit system is understandable for all the parties. And first, we developed the grand vision about the digital system in a digital world. And this vision says that the SI, as I described, or as it is described in the brochure, is a coherent foundation for the representation and exchange of measurement data, enabling interoperability and reproducibility in all scientific and technological domains. So the objective in the long term of the working group in SI, digital SI, in this initiative is to develop a framework that complies with the FAIR principles. It's principles that say that data have to be, it's an acronym, they have to be findable, accessible, interoperable, and reusable. So this is what FAIR means. And it should allow all aspects of the international measurement system, measurement results, uncertainties, traceability, and provenance to be accessed and interpreted digitally, enabling machine-to-machine communication and analysis. So the objective of this vision, it says that it's necessary to develop digital database that enables the exchange of measurement results with all its implications, traceability, uncertainties, etc. That is, and this should be possible in a digital environment, machine-to-machine communication without human intervention. The other objective, as I said, is the development of alliances to make progress in this sense. And the Cipm proposed other organizations on digital transformation, and we did a joint statement of intent, and what it says is that it recognizes that the government, the industry, the academy, and civil society have been working towards the digital transformation for many years, and for doing this, they are establishing systems to collect, aggregate, analyze, and interpret digital data, introducing networked sensor systems for diverse scientific and industrial applications, and sharing data at local, national, regional, and international scales. In this context, the unit, the International System for Units, has a particular role in the international quality infrastructure, providing confidence in the accuracy and global comparability of measurements needed for international trade, manufacturing, human health and safety, protection of the environment, global climate studies, and scientific research. And maintaining this confidence in the accuracy and global comparability of measurements will require the creation and adoption of a full digital representation of the SI, including robust, unambiguous, and machine-actionable digital representation of units of measurement and of measurement results and uncertainties. So what they do, the entities that signed this document, they commit to support in an appropriate way to each organization to develop and implement and promote a digital SI framework as a part of a wider digital transformation on the international scientific and quality infrastructure. At the beginning, this declaration or statement was signed by Cipm and the Scientific International Association. It was signed by CODATA, which is the Committee for Science and Technology, and IMECO signed it, the International Measurement Confederation, and it was signed by OIML or CIML, represented by its president. And these were the original signatories, but ISO signed too, and ISO is a very important player in this context. I also said we were going to speak about what we are preparing for the next general conference. In the general conference, we have the representatives of the states, so a resolution from the general conference has a very important status because it's like a diplomatic agreement among countries. It's not the decisions of NGOs or of representatives of the National Metrology Institute. It's the decisions taken in a general conference. It's agreements among states. The CIPM is proposing for the next conference a resolution that is about digital transformation of the international system of units. It's aligned with the other documents, and the resolution is very long. I'm just highlighting the important parts, but it's aligned with what we saw previously. The resolution anticipates that maintaining confidence and precision and comparability requires a comprehensive a representation that's robust and not ambiguous and actionable and usable by machines. And this gives a mandate to CIPM so that they continue its outreach and engagement initiatives to ensure that the meter convention naturally extends its role as a globally accepted anchor of trust for metrology into the digital era. And it asks CIPM to undertake the development and promotion of an SI digital framework that includes globally accepted digital representation of the SI, and that facilitates the use of digital certificates as a part of the infrastructure for quality that's robust for the global recognition of the national results. So what is reached as progress in CIPM will be a basis for, this will naturally be extended its role for its acceptance for digital certificates. And then it asks to adopt the FAIR principles, findable, accessible, interoperable, and reusable for the digital metrological data. And then the work that is being developed in parallel to these to these elements that are more of a policy framework. But from the technical point of view, we're working in the adoption and the development, but more the adoption of formats for the units in the world, in the digital world. What does this mean? Most of the software and the data management tool doesn't have support for associating with units with numbers. So the information is managed and stored without values without a unit. And some disciplines have already developed a few years ago formats for representing units, such as UCOM and QUDT and others. But these are formats, niche formats of very specific sectors, but there are no general agreements on how to represent this so that we don't confuse different elements. So we have 3 paths, not deciding for a determined format for units, but establishing clear requirements so that any unit complies to be for being accepted as a unit that can be trusted. And we could also develop columns in the brochure that compares this data and provides an application that could do the translation from one format to another. Another path would be decide one only format based on the previous criteria. This would be the most rigid one, to have one format that would be under the control of Cipm and work on it with the other organizations for quality infrastructure, and decide unit formats of the ones that exist as the main one, where we are going to structure the documents or the database that are under control or BIPM, and accept any other unit format that another community uses in relation to the previous criteria. And finally, we will use option 3. Currently, there's not a single format that's ideal. There are 2 philosophies. One is that to have identifying elements, individual ones for each individual quantity, or dynamic systems that build the units with base units, like UCOM and SIU and ITX. There are advantages and disadvantages.
And we are currently considering several examples for this. That is in order to develop a definition. An important example would be the development of the digital calibration certificate, which is being proposed. So our main conclusions could be that we should maintain the confidence achieved in terms of what we've been mentioning, and this requires the creation and adoption of a digital SI, which would have to be broadly discussed and accepted. The use of digital certificates, such as those that would be part of the existing solid infrastructure, is important and requires the use of broadly accepted units. And the meter convention would have to broaden its roles as the main aspect of accepted globally for metrology in the digital era. And the Cipm must propose a representation system for the units, which would be used as a reference for all of the quality infrastructure. So we should maybe be open in terms of what system we're going to be used, or maybe there should be several systems accepted. So the question is, should we have one system for all metrology institutes and calibration laboratories, or should we have several? My personal opinion is that we should choose one of these paths. So thank you very much, and I'm open to any questions you might have. Thank you very much, Hector Liais, for this excellent presentation. And based on what you just mentioned, we'd like to remind everybody here at this event that you should send your questions through the Zoom chat, and those of you who are connected through the social networks representing the various metrology institutes, you can also send your questions through the comment boxes, and we will be joining those questions together, and we'll be asking the said questions at the end of this block. So thank you, Dr. Hector Liais.
Transformation in the quality infrastructure will be in charge of Dr. Sasha Einstedt, who comes on behalf of the OEML. Dr. Sasha Einstedt is the leader of the working group Coordination Digitalization of the Presidential Staff in the German Metrology Institute, PTV. He received his diploma in mathematics in 2008 at the U Berlin and his PhD in theoretical physics in 2012 at the TU Berlin. From 2008 to 2017, he joined the group Mathematicals, Modeling and Data Analysis at PTV. His main research areas are signal processing and sensor networks. Thank you very much for being on this event. Welcome, Dr. Einstedt.
Thank you very much for the invitation and the introduction. In fact, today I'm not speaking to you on behalf of my role at PTB, but on behalf of my role at the OIML. And as was mentioned before, there's a new task group which was established quite recently at OIML. And I will introduce you to the background and motivation of that group and present you some of the ideas that we have in mind for the roadmap in working in this group. Just very recently, last week, I was nominated by the group as a nominated chairperson. Still have to be approved by the CIML, hopefully in October this year. Before we go into if we go into the quality infrastructure, let's have a look at the metrology aspects in digital transformation. And there are two sides. One is the traditional, so to say, the core metrology aspects. And the other is the digital technologies and the resulting new challenges for the society, for the quality infrastructure, in particular also for metrology. And there are several of them. Here are some examples: additive manufacturing, autonomous driving, big data and related technologies, the Internet of Things in industry and elsewhere, and artificial intelligence or AI. And these new technologies can be found in several areas already. In the health sector, there are more and more applications based on artificial intelligence. In the industry, the companies use big data to analyze and improve their processes and make their production more efficient. Climate monitoring, observation, and also regulation on that is only possible by using large amounts of data and interconnected sensors. And society is using many technologies based on some of these aspects, like artificial intelligence, in the future also autonomous driving, or already today parts of that in automotive. So these bring us to new challenges for the quality infrastructure, posing new requirements also on metrology, but also bringing new opportunities for metrology, like we can make our own processes more efficient by using digital technologies. We can use virtual instruments, of course, need to do metrology for that. Virtual instruments such as a simulation of a measuring instrument in Industry 4.0 or IoT. But we are also required to react to digital technologies, like providing our services using machine readable information, The digital calibration certificate was mentioned before. We can use or should use the same technologies also for providing information about our reference data, reference measurements, but also may need to provide reference data for instance, the assessment of artificial intelligence. And we may need to develop new aspects like digital product information. A certificate about the calibration or the conformity of a product is not sufficient in the digital era. It needs to be provided in the digital form as digital product information. But you can also draw this error on the other direction, because metrology brings confidence and accuracy through core metrological principles like traceability and comparability. And this poses new requirements but also opportunities for these new digital technologies. Overall, you can summarize these under the quality of data and algorithms. Metrology brings security to data by having a look on the processes behind how these data is produced. Interpretability of data is only possible if you understand the measuring instruments. Integrity of data by comparability and by making sure that the measurements are traceable to the SI. Digital representation of the SI, as mentioned in Hector's presentation. Robustness and explainability of artificial intelligence and other intelligent algorithms based on core methodological principles like traceability, comparability of measurements and algorithms. So you see, there is a strong interconnection between digital technologies and metrology. To broaden this point of view into the quality infrastructure, I want to take a look at the product lifecycle. And that's basically the same, being it for the digital or the before digital era, so to speak. It all starts with the development of the project, with the design, with the research and development of it. Then you have the manufacturing, distribution, operation, and at some point in time, the recycling of the product. So the quality infrastructure will remain necessary for this product lifecycle. You will need standards specifying requirements for the development, manufacturing, distribution, operation, and recycling. You will need metrology to maintain trust and confidence in the measurements necessary to confirm adherence to standards. And you will need conformity assessment for all this as well. And of course, all the other elements and aspects of the quality infrastructure. But still, things change with digital transformation. And one is that with these new technologies, these new possibilities, products will also have product information provided in a digital way, like a digital certificate, a digital twin, some cloud platforms being connected to the product or being used together in conjunction with the product, and so on. But the physical products come with digital information, and the quality infrastructure needs to be ready to work with this digital information and contribute to the digital information. Examples are smart standards, like a machine-readable standard providing information about what is contained in the standard in a way that can be understood by an algorithm. The same holds for certificates. A calibration certificate, a certificate of conformity, needs to provide the information in a machine-readable way that can be understood by a software that can be integrated easily into a cloud platform. And again, also the quality infrastructure bodies need to be able to work with cloud platforms, being it provided by the manufacturers, the users, or whoever else. The quality infrastructure should also make use of artificial intelligence, wherever that makes room for making the processes more efficient. And last but not least, the quality infrastructure needs to work together to develop something that may be called a digital product path. So a simple logo or signature or anything else on the product indicating its conformity with standards and access to markets is not sufficient in the digital era. This information needs to be provided digitally. And this brings new opportunities. Like I've mentioned before, when we use the digital technology, we can do more than we can do today. We can bridge all the different processes in the quality infrastructure, make them more efficient, bring them together, and in the end, have kind of a digital landing place for all the information available for the product to indicate to the user, to the manufacturer, market surveillance, and so on, the status of the product and its conformity to standards and regulation. So what are the digital technologies that we're going to see for the quality infrastructure in the digital era? Well, we will see common data formats because we need them to make data interoperable, to make let become reality this concept of a digital product path. And we need interoperable digital interfaces for automated and streamlined processes. We will need the information from standards, regulation, and certification accreditation in a machine-readable way to allow and enable intelligent manufacturing. We will see the application of digital twins for the assessment of products and new services. And we will see aspects like continuous quality and conformity assessment. So not step by step or after a certain amount of time, but in a continuous way. For instance, based on sensor networks monitoring the health of a product or an infrastructure. And this will also be done by the effective handling of software updates, or for the effective handling of software updates and self-learning artificial intelligence. And this makes clear, I think, the need for the now signed joint statement of intent mentioned and showed by Hector. It's necessary to bring all the bodies from the quality infrastructure together. And I'm thus very happy that we now have the major bodies of the QI on board and more about to follow and sign the signature. And it's not just signing a document, it's really a change of mind. We need to work closely together in the digital transformation of the quality infrastructure because it's a joint effort. And the OML Digitalization Task Group is one way for the OML to bring this to life, to let the joint statement become reality. So it's not an OML activity. It's really an activity meant to reach out to the world and reach out to the other bodies of the quality infrastructure to work together. We will, in the task group, we will work to help and consult OML in preparing for the digital area, the development and adherence to smart standards, the making use of digital platforms and AI in legal metrology. Help in the identification recommendations for further development in the OML certification system, for instance, for intelligent digital processes. Supporting the activities of OML for emerging countries to overcome technology gaps between member states of OML, but also between legal metrology and industry in general. And supporting international activities like for conferences and workshops. Looking into some of these aspects in more detail, starting with the consulting of OML and preparing for the digital era. When you look at the recently published white paper by the project EDIS, this shows the roadmap of the standardization community, the roadmap in the digital transformation. And it makes clear that right now, in most areas, we are mostly at level 1 of digital maturity. We use digital documents. We send around PDF documents. We send a PDF document of a certificate to our customer. We send it maybe a PDF document for a conformity assessment to our customers. And we may receive a Word PDF documents or something else from our customers. But this is not digital transformation. This is only the very, very first step, and it's kind of a 90s technology, really. What is next is the machine readability. Information must be provided in a way that can be understood by software, by machines, that can be integrated into existing infrastructures. This is level 2. And in this white paper by the standardization community, they go up to a level 5, the machine controllable content. This is something really far in the future, but it shows where development is heading to. And that is that software will write standards. Software may write certificates. We are talking about remote calibration for quite some time now. This can also be done automatically. The same for conformity assessment. Maybe in the future, a software will control the adherence to standards and regulation of the product and will update a certificate automatically based on some smart standard, some smart contract in the background. And we need to be ready for this. And this is a long road and development necessary to do so. In the certification system itself, when we look at the product lifecycle shown before, we see that we also need to elaborate on this and need to embrace digital technologies here as well. So the digitalization task group will develop concepts and propose those to OML for enabling legal metrology to participate in this digital transformation aspect. Like, for instance, the digital product path becoming a reliable and secured information about the certification status of a product. Digital processes and communication between the bodies of the quality infrastructure beyond country borders. This sounds trivial in today's technology, but it's far from trivial in the quality infrastructure across borders. And supporting OML seems to overcome technology gaps between member states as well as between legal metrology and industry also means to speak and to talk about technologies and how to make use of technologies. And it starts with communication. It starts with making available the knowledge and the competence between the members of the OML, between the members of OML and the industry partners, the customers, and the metrology community overall. And some groups are fairly advanced already. This picture here shows a graphic from a PTB website showing an overview of the different tools you may use for an interaction, for communication with each other, depending on the number of participants and the degree of interaction you need. And we need simple tools like this for digital transformation and legal metrology as well. And this will be one aspect of the DTG, the Digitalization Task Group of OML. And last but not least, we need to go out there. We need to make people aware that there is something like legal metrology. We need to talk and discuss with the expert of digital transformation and digital technologies elsewhere in the quality infrastructure. And one way we do that is by publications in the OML bulletin, but it's also by taking part in conferences like this year in September, the IMICO conference on digital transformation, where there are special sessions on several aspects in digital transformation, pathways to digital transformation, machine readable certificates, sensor network metrology, metrology in pharma, and now also a special session on legal metrology organized by the OML Digitalization Task Group. Thank you very much, and I'm open for questions.
Thank you very much, Dr. Eichstadt, for your presentation of this important topic of digital transformation in the quality infrastructure. En este momento,
so at this time, I would like to give the floor to Dr. Hugo Gasca, who will be talking about digital transformation in CIM. he is the current chair of Working Group 14, and he's going to be talking about digital transformation. And he is also working for the Mexican Working Group on this topic, and he is also the vice chair of the IMECO TC6 group on digital transformation. He has a PhD in mathematics and statistics, and he's been working with the National Metrology Center, Cipm, since 2013, specifically leading the National Standards group, and he works in statistics as well. It is a privilege to have him here today. Go ahead, Hugo Gasca, you have the floor. Thank you. Good morning, everybody. It is a pleasure to be here with you, Claire, Hector, and Sasha. Thank you very much for the topics you've spoken about here today and the information you've shared, because this makes my presentation much easier. So thank you for introducing me, Herman. I'm going to be talking about digital transformation at Cipm, and I'm going to be talking about the work we've been doing. So I'm going to talk a little bit about some of the topics Sasha and Hector have spoken about today, so I'll try to be brief. So, as Sasha mentioned, when we talk about digital transformation, we also we have these technologies, specific technologies available. So we talk about cloud technologies, big data, the the blockchain, the Internet of Things, artificial intelligence, digital twins. We talk about 5G communication networks, and we're already working on 6G actually, and sensor networks. So we're working with these aspects, and this represents new challenges. We also have this whole cycle, and we need to think about how to use these aspects within metrology and the activities we are currently carrying out. So these technologies are being used, and we need to think about how metrology can contribute, for example, robustness and other elements. So we are talking about traceability, comparability, modeling, and how the biases also have an impact on the technologies and the services we're offering to our citizens. So now, as you can see, Hector and Sasha have mentioned that these efforts involve various levels. We have BIPM, CIPM, so this is a global effort. I don't have, for example, we have Euromet here with 2 goals, which are quite important. We have the digital calibration certificate. We have 1448 and 1449, which refers to research data management. We also have the Asia Pacific area. We also have East Europe, IMECO, TC6, which Sasha mentioned. In America, we have NCSLI, which is from the accreditation perspective. So, and in America, we have MWG 14. That is an effort which doesn't focus specifically on one thing. We're all working together, and we all want to achieve certain steps in this global effort. Now, talking about the Cipm region, the American region, we have Well, a specific perspective, which might be my own personal perspective, but I've tried to make it as international as possible. So I'm focusing on the activities within SIM. So in 2017, we had the first publications on digital certificates, at least the ones I'm aware of. That's from the P2B perspective. That's the Metrology, National Metrology Center in Germany. So in 2018, there was strategic planning in Mexico at Cipm. So there was an external audit conducted where we received support from Argentina, Canada, and Germany. And that's when the first recommendations were made in order to focus on digital transformation. And in 2019, there were strategic workshops in order to make us aware on this need that involved Peru, Colombia, and Bolivia. In 2020, we had to face the COVID pandemic, so there was a new reality. And towards the end of the year, there was a strategic workshop planned, which was going to be held in Argentina. It was going to be an on-site workshop. However, it was decided that we were going to hold it virtually. So there was a lot of collaboration within SIM. And this is something that was... well, we focused on working on digital transformation, basically. So in 2020, there were many things which came up based on this virtual workshop. So there were 5 sub-working groups, so we call them task forces, basically. And this was all on digital transformation. And there was an important event here, which I'm showing with those green arrows. That was the M4DT Day. That was, this is... something we do once a month. That we have a meeting once a month in order to address certain topics with international presenters in the region to address digital transformation topics. And so now that's how we address these metrology aspects. We also created a website in order to upload and share this information. This website was created or was decided on during this first virtual workshop because we need to interact and develop information, and that's the reason why it was created in a Cipm server, and you'll have the address at the bottom. So if you'd like to visit it, there's additional information on that workshop, but basically it's a content that's being generated at the SIM level.
For the end of the year, SIM was analyzing this that had happened in 2020, and for the end of the year they formalized the creation of this group in January. And this formalization at that moment in time, it included 21 of the economies of America, and now we have, I think, 22 economies represented in this group formally. We also published these FAIR principles at a global level, and we made international events. And there is a second virtual workshop that we carried out in September last year. There was a second strategic workshop, and there were also international collaborations with the MECO, and there was also a project that was being worked on with the IDB, and it is authorized in the middle of last year, and it started in those dates. And this year we have supported training in these topics. We have planned Zoom workshops for September, the third virtual workshop, and we have had a third strategic workshop for sharing experiences. And there's another one that helps us define a strategy as a region and as institutes. And for the IDB project, I will speak about this a little later, but we have a pilot project for developing technology with digital components. And we also have an effort for making progress in the implementation of digital certificates. This is a roadmap for this effort that I'm sharing so that you have an idea. This is a draft. This is a vision for 2030. And this started like stairs. And then I started adding other concepts to the idea. We started with the first milestone was to have a digital certificate. So as Sasha said, there are 5 levels. Most of us are in the first level. We are working strongly to reach the second level of maturity, I would say. And these, to achieve this, we need to be based on the international system for units. And we need to work in the amounts and the type of quantities, but we will speak about this later on. Also, the DCCs we've been working on these, and it's important to comment these. And I'm referring to the activity that it doesn't limit the activity of metrology institutes. We have producers of reference material. So there are digital certificates for this. We have CMCs or capacities or capabilities for calibration and measurement and accreditation. So we need certificates, digital ones that say this, that back this. And we also had from the legal part approvals of the model and verifications of instruments. And we would need to cover this with a digital version for these certificates too. And then, as we mentioned, as Sasha mentioned, we have big data processing, interrelation between systems, artificial intelligence, cloud technologies, additive manufacturing, and computer assistance for design, manufacturing. We have the devices or device networks of the smart devices, and all of these are enabling technologies. But I would think that if we have the digital certificates, it's just a matter of time to put information in them. And even if we have them in the cloud, we need a mechanism to manage them in a logical manner for us. And there we have the digital twins. This should be managed by humans, and it has to have a counterpart, a physical counterpart. And we need a behavior that's associated to the physical element. And this is a second important milestone. And this would allow us to take the industry to 4.0 level, or for manufacturing services 4.0, because it's not only the industry. We've got vehicles, houses, hospitals, or smart governments. There are services associated to all of this. So this is the scenario that I'm looking at for 2030, thinking about level 5 in the future. And how far in the future is this? I don't know. 2030 is... I'm going to share about the IDB project. It has 3 blocks. The first one is about experience exchange for building capabilities in the region, and for automation of laboratories and remote calibrations. And we are making efforts to implement these. The second block is research projects and development projects. We have 4 projects that have been approved. One of them is the development of measurement instruments with digital capacities, like the thermal hydrobarometer that we we'll use in calibration laboratories. And the third block has to do with the creation of regional public assets. And we are working on a proposal for a blockchain proficiency test system. So this is a definition of a very high level about this project. And it is there's an economic contribution from the IDB and in work in hours, human hours, for each one of the metrology institutes of the region. And I would also like to share at a general level, we have more than 10,000 human hours in the effort that we have carried out. And this is the information that I have for this. Challenges and threats, we have challenges. The amount of information that we need to manage is very, very large. Also, we need multidisciplinary collaboration, because it would be an illusion to think that with very few resources we would be able to do this. We need to collaborate for doing this. And what are we speaking about here with challenges? Hector said there's an important effort and a considerable base in the international system for digital technologies, and there's a great deal of work to do too, but we need to work in standardizing measurements, and the information that we generate in the digital certificate is interpreted by humans, and we think that a machine could interpret what an amount with a unit means, and a digital unit is not enough. We need to know the purpose or associate it to other elements. We also have the possibility of working in declaration for standards at a digital level. For example, the maximum tolerances that are in the standards or in some standards, this could be smart contracts. And at some point, the machines could validate or not if we comply with this standard, depending on what we're measuring. And this, more than a challenge, is a threat. The political and financial stability, there are movements in the whole world, and we have the pandemic in particular, and we might have another pandemic with this new pandemic, and there's a threat of a long war. So we have problems basically because there's tension at an international level, but it also affects our budgets within the national institutes, at least partially in the region. We have a staff turnover currently, and when this matures, we are going to lose brains in the National Institutes of Metrology. These persons who work in digital transformation are going to be demanded out there. So the idea of a unique market of a digital degree is what promoted in Europe, what promoted the calibration certificates, and also harmonization for international trade in the region. We have done some work on this, but we only have commercial agreements in the region. So we need to work on this to support it from the metrological point of view. And finally, I would like to share a reflection that I had last week with some persons, some important persons and for this topic, and the new trend and the new technology for digital transformation is the new companies that are going to become unicorns and that represent economic development for the countries where they are established. And what I would like to share is that these companies are going to, they have another paradigm, they have another speed, and they managed to consolidate it in less than 2 years. We have 35,000 candidates to be unicorns. And each time it's faster at the creation of these companies. So we need to pay attention to this and how the metrology institutes could help these companies to maintain themselves in time and to have a metrological support for generating confidence in these services. And in order to finish, I'm going to comment an example here. Maybe it's too much detail, but this is one of the sections from the content of the digital certificate. Here we have a quantity of 20.1 degrees centigrade with an expansion of 5 with and the factor K equals 2 and P equals 0.95. And under this, we have the form that has been proposed by the current scheme, where we have a control on the numeric amount and uncertainty. And the digital units are here in green, degrees Celsius. And the measuring unit is not necessarily, I'm putting here temperature, but we could have something different like air temperature or environment temperature. And we need to work in best practices for each magnitude. And we need to know also about the efforts at an international level related to this, because there are other efforts trying to standardize these types of quantities. This is what I had prepared for today. Thank you for your attention. Thank you, Dr. Hugo Gasca, for this presentation, where he shows us in a clear manner, and also it is aligned with the other presentations and digital transformation in the region. And we will begin right now with questions and answers from the persons who sent it to the Q&A window in our Zoom meeting. It's important to say that there was a question for Dr. Sasha Einstedt, and he answered this to this question in the chat window, but we will not repeat this because of time. We have several questions for Dr. Hector Liais, and I will start with the first one. It's from Francisco Flamenco, and it says, how can the statements of Cipm can affect, referring to a digital framework and the international system, to a calibration laboratory or to another, to any other laboratory that works on metrology? Thank you, Francisco, for the question. But this is what I was trying to present. The Cipm has as an objective to propose the use of a system of digital representation of the units for measurement within the international system of units to the metrological community. That includes the National Institutes of Metrology, logically, and the calibration laboratories. So we have a different format that are accepted because they're used in other communities, and it would be impossible to unify all of them in one. So the idea would be to have in Cipm a proposal of the use of a digital representation of units that is then adopted by the National Institutes for Metrology and the calibration laboratories. So in that way, the proposal of Cipm is going to reach the calibration laboratories. I don't know if the answer is clear. Yes, doctor. In fact, the idea is that I am in charge of a laboratory, and so I asked myself, how is this going to affect me? And I need to start thinking about this. And what digital representation of the units, or the ones in the brochure that have been published recently, the 9th brochure, it's the same units where how we express the measurement and calibration capabilities in the Appendix C of the Mutual Recognition Agreement. So these units have a representation and a format that is understandable for humans. The idea now is to have a representation that's globally accepted for machines. And this is the idea of taking this to calibration laboratories and to have a unified format. And about the other question, it is impossible to think that we can take this to one sole format to all of the communities, because there are some communities that have different representations. For example, the medical or biological community uses a representation called UCUM. It might not be the best one for metrology, traditional metrology. So the idea is to propose a format for the metrological community and accept the other formats, and having software and applications that allow to change formats in a transparent manner for the user. So the idea is for BIPM to provide this service of converting a representation format to another. If I want, for example, to read the SMC that's in the Appendix C with another format, the database from BIPM should have these tools for conversion. Thank you very much, Dr. Liais. And the second, he also answered the question about the format. So I will continue with the next question from Jose Lajes, and he says, is there a reason for which ILAC hasn't signed or is not a part of this joint declaration? No, there's no explicit reason. I think Cipm is having discussions with ILAC so that they sign the joint declaration, just like ISO. And I think the reason is that ILAC is a little bit behind compared to the other organizations of quality infrastructure in this topic of digital transformation. But having ISO signed and BIPM and other entities, the main players at an international level, the four-part scheme, BIPM, OML, ISO, and ILAC, which is the four legs of the infrastructure for quality. When since three have signed, it's very likely that in little time ILAC will be signing. There's no explicit declaration that there's a disagreement with that. I think it's just a matter of time. And internal things to have the approval to sign. Thank you very much, Dr. Liais. We have room for one more question for Dr. Hugo Gasca, and the rest of the questions will be answered in the chat window because of time, and we still have to do an important part of the event. Dr. Hugo Gasca, with regards to the digital calibration and the certificated reference material, this question is from Cristian Paredes. In principle, would we adopt the path that Dr. Liais mentioned of having one only format and having room for other formats that comply with the criteria? In principle in this case, I think it's possible to unify them because these could be PTV and NIST efforts. In CENAP, we have an effort for digital certifications for reference materials. We are starting with this, and these are the ones that I know. But as Hector said, there's material that's already being produced, and producers that have the capacity to issue these digital certificates already. We could not stop them. So it's very likely that we have several versions or formats, and we will have to see how they coexist. Thank you, Dr. Gasca, for this answer. And we will thank Dr. Liais and Dr. Eistad and Dr. Gasca for their contributions in this event and answering the questions of the participants. I'd like to remind you that the other questions will be answered in the chat window. And with this, we finish our first block of presentations. And right now, we will start with the discussion panel, which will be formed by representatives of the 5 subregions from the CIM. We'll speak about Noramet, Carimet, Camet, Andimet, and Suramet. And let's remember that it's important to do your questions in the chat window. And when we finish the discussion, we will answer the questions. Don't forget, as we said, to say who you are asking the question to. In this occasion, we have Diego Copa, the engineer, Diego Copa, and he will be the moderator of this discussion table. He is the current vice president of the working group Metrology for Digital Transformation of the Inter-American Metrology System. He's a metrologist from the Flux and Volume Department of the Institute, from the INTI Institute from Argentina, and he's the responsible for promoting the digital calibration certificates in metrology and management of quality in INTI. It's an honor to have engineer Diego Copa here and for him to moderate this discussion table. And welcome, and please, the floor is yours, Engineer Copa. I'm sorry, I was muted. Thanks. Thank you, Germán, for introducing me. Welcome, everyone, and we will continue with the next block. I will explain the table, the mechanisms, and then I will introduce the topics, and I will introduce the panelists. The topics that we're going to work on is going to be strategic of the Institute for Digital Transformation, automation and implementation of processes in INMs. And within this, we'll have lab automation. We will ask about progress related to digital certificates and standardized metrological formats. And we will speak also about technologies in the cloud. We will also discuss challenges that INMs and other players have in the medium term for digital transformation and the possibility of regional cooperation. For this discussion table, we will have 5 representatives of the CIM, subregions of CIM, and I thank their participation. From Andimet, we have José Antonio Dajes Castro. He is a director of the Peruvian Metrology Institute for in 2011-2014, he was the president of the System for Metrology and Inter-American System for Metrology. From CAMET, we have Diana Marin. She's a director of the LCM in Costa Rica. From Noramet, we have Hector Liais. He's the current general director from CENAM, Mexico. And from Sudamet, we have Daniel Volpe. He's the director of Metrological Institute of Uruguay, and he's a chemical engineer of the Uruguay University. And he has a master's degree in bioprocesses in the Catholic University of Chile. He is a coordinator of Suramet, and he's a member of the Director Council of CIM. And from Carimet, we have engineer Rubén Neris. He's a mechanical engineer and electrician from the University of Santo Domingo, and he has a master's degree in physics from the same university, and he has experience for more than 25 years, and he's a director of the Institute of the Republic of the Dominican Republic for metrology. So everybody, be welcome, and let's begin with the discussion. The Institutes for Metrology, when they were aware of the magnitude of the current changes and future changes, they started developing different strategies for this topic. For example, let's ask Diana Marin so that she tells us how in her institution, which is LCM and then the CAMET region, they are working on digital transformation. So please, Diana, the floor is yours. You're muted. Diana's muted.
O no se te escucha.
Or we cannot hear you.
Ahí, a ver. No.
There.
Seguimos por el próximo y después.
Let's continue with the other one, and we will continue with you afterwards. Victor?
Avanzar. Si quieres hacer tus comentarios.
Would you like to make your comments, Victor Lizardi? Yes, thank you. Can you hear me? Oh, can you hear me? Oh, now we will continue with Victor and then with Diana. Victor, please. Yes, thank you for inviting us to this Cipm event. I am not going to name everybody, I would think, but I would like to thank Cipm. Yes, in fact, we need to discuss this topic, and as Hector, Sasha, and Hugo said, everything, all of this requires a joint effort because we are all based on a metrological structure, and it is strategic to rethink how we present this information. This information that is required to be presented in the digital calibration certificates. We have heard about the difficulties that we have for this and the initiatives and everything else. But I think that what we need to be clear on is that in each institute, in each region, we are carrying out an effort, an important one, that's oriented by this compass that Hector Liais explained at the beginning, and that makes us add ourselves to these initiatives. And while speaking with Noramet, I would say that the efforts that were being carried out in Senam and other institutions are efforts that are oriented to the management, but they implicate differences in progress and emphasis in certain topics, but they are all specifically important.
For example, at the NIST, they've informed us that they have different formats to report calibration. I mean, at least that's what they've said. And they've emphasized on the fact that the calibration reports aren't digital certificates. And that shows that there is a very solid foundation. However, it's necessary to standardize them based on what they've explained to us. And, the NIST has emphasized on the fact that the scheme doesn't include any reference materials, and they are specifically concerned on the fact that there are no reference materials, and Huogasta has also emphasized on this, and there is a specific need for special work regardless of the challenges that the digital calibration certificates represent in other areas or regarding other services. So the NIST has also informed that they are going to host a workshop in September. That's a digital workshop in order to try to address the needs of the stakeholders in relation to the digital certificates. And with the information obtained, they're going to create new strategies to address this issue. Now, at the NRC, so the NRC is emphasizing the difficulties faced because they collectively, that's referring to the NRICs and the NIST, they are facing difficulties due to the lack of experience in this area. However, they are working hard in order to provide a foundation or an infrastructure for digital metrology in order to allow consumers at any given point, in order to allow them to innovate so as to be able to have more robust services. And the NRC is also emphasizing on the fact that we need champions to innovate at all levels. And they're also emphasizing on the fact that we need many metrologists involved in this area. So, and we also need to increase interest of stakeholders. This means the MRC partners and the NIC members, and I think we can simplify this by just saying, well, we need the involvement of all stakeholders in the metrological systems. So I'm not going to talk about Cipm in detail because I believe that Hugo Gasca, in one of the graphs presented, spoke about what Cipm has been doing regarding this topic. However, I would like to mention the fact that everything Cipm has done, and I'm very grateful for this, but everything Cipm has done since 2019 was because in 2019, in fact, it was the 25th anniversary of Cipm. And for this reason, the Hector Liais, Joaquin Ulrich, and Alan Steen offered to carry out an analysis of Cipm's trajectory over that 25-year period. And I'd say this was a very valuable input for the strategic planning within Cipm. So that report very clearly shows what Cipm's evolution has been over that 25-year period, because it highlights Cipm's strengths, and more importantly, they've established a series of recommendations which have been a very clear guideline for strategic planning within Cipm. So very specifically, I would also like to highlight on the fact that they have specifically been focusing on digital transformation, which has led to what we're doing now. And for that reason, we have a group which has specifically been dedicated to this, and it has been led by Hugo Gasca, in fact. And you all well know that he was elected to lead Cipm's efforts towards digital transformation. And, well, I believe that we're all in very good hands, and we are all highly committed. This is in Cipm and in Noramek. We're all very, very committed towards achieving this. Thank you. Thank you, Victor. I would like to remind everybody that you have 3 minutes maximum to speak, so as not to, or in order to give everybody time to speak, basically. So now, Javier, I think you have the floor in order to talk about, or Patricia, actually.
Or Diana, actually, you have the floor. So can you hear me? Yes, we can hear you now. So I would like to talk about something which we believe everybody is aware of, and this could be an option. Well, at the end of the day, we're going to be talking about digital transformation. So in 2018, the state of Costa Rica and the region began becoming more concerned about digital transformation, and we began thinking about more efficient platforms, and we began thinking about challenges. So we began thinking about what digital transformation was, and within this transformation process, and we began working on a strategy, because we can't say that digital transformation is only including tools. We're clear on that, and we began learning about what it was. So digital transformation is really the way in which our laboratories work, how our NMIs work, how we interact with the users, how they're interrelated with the business system, and how these technologies are interrelated with automated processes and how to make them efficient. So digital transformation, as we've mentioned, isn't a mix of tools. It's the intelligence behind those tools in order to achieve the desired result. So within the SAM and in the region, we've established a strategic plan at the DECAMED level, and we have been working on analyzing our challenges and needs. And we've also worked on automation through Lab2, the automation of the calibration processes specifically. And in order to collect data, we need to do this in an automated manner. And after that, we moved to transferring data to PDF and then to XLM, so as to integrate this in a platform and to integrate everything in the cloud. So now this is the strategy we've been working on. So our purpose isn't to have just a digital strategy, but we want is to be able to quickly respond to this changing context. And what are we referring to? Well, when I began researching the digital transformation concept, and now when I began researching this, I found out that there was a BUCA strategy that the U.S. Army was using. So now this involved the complexity and ambiguity aspects that the U.S. Army was focusing on. So I think that what happened to us now is that the pandemic pushed us towards doing this and towards working towards this objective. So now I think we're all hyper-connected. Everything is hyper-connected, and we're all hyper-connected. So I think technology needs to respond in a more streamlined manner. So it's posing new challenges, and we're responding with a higher speed because we've had to do this. Now, in terms of certificates, I'm going to be talking about that later. But since we've been developing this strategy in a faster manner, we are working towards achieving more results in a way that work for us, and we're using innovation processes or innovative processes with the new solutions which we are testing based on markets which are constantly changing. But it could be that we'll find a solution which won't work in the near future. However, we are implementing our efforts, and we're developing Metrologic digitalized solutions based on the challenges that this context is posing. Thank you very much. Thank you, Diana. So I think I've got new things to research now, but now we're going to continue with Daniel Golpe. Go ahead, Daniel. Are you there? Yes, I'm here. Can you hear me? Yes, we can hear you, Daniel. He has a lot of echo, so I'll do my best to translate what he's saying. So I'm very happy to be here, and I'm very happy to be here with some of my colleagues. So I wanted to talk about what the strategy has been in terms of digitalization. And this is fundamentally due to the processes we've had based on interconnection with clients, which is a topic which is very important. I'm going to delve in deeper in terms of transformation and the work metrologists are doing in terms of development, participation in intra and inter-region projects with which help us understand synergy towards the growth of our institutes. Something extremely important regarding the incorporation of technological tools is related to calibration and the development of reports and everything regarding measurement and improvement processes. And it's also important to mention strengthening laboratories. So our purpose is to focus on what's happening within our countries, but abroad as well. So I'm also going to be talking about achieving interconnection, as Diana was saying. Linked specifically to an exclusive network which guarantees the maintenance of software and hardware. So we need to focus on the time available according to existing standards. So the purpose is to interact and achieve results within or in times when demand is constantly growing. We also need to reduce errors, human error as well. We need to increase the accuracy when working on increasing the results or on achieving the results we'd like to achieve. Thank you very much. Thank you very much, Daniel. Would anybody else like to make any other comments? If you'd like to make additional comments, please go ahead and do so now. If not, I will move to the next topic, which would be the process automation, specifically within metrology laboratories. Ruben Liais, what can you say about this topic within Indocal and Inmetro? Ruben Liais, you're muted.
Ahora, ¿me escuchan?
Ahora sí.
Can you hear me?
Okay. Gracias, Diego.
Por favor.
Thank you, Diego.
Los laboratorios de metrología del Indocar son
The metrology laboratories in Indocal were created recently. We began working in 2014. That's when our infrastructure was created by law. So the first thing we have focused is on our automation process, because that's what allows us to minimize errors when we are carrying out our reading processes. And we have been focusing on optimizing our processes in general. We have made progress with our processes, and we've implementing the automation in the temperature and mass processes, and our metrologists in the respective areas have developed programs based on LabVIEW. And in the electricity laboratory, we have also implemented automation. And specifically, this laboratory has acquired a software that's a commercial software, which allows us to program the sequence of the calibration points, which has translated in the possibility of saving time. Because, well, this is something that is a pro for the client when it comes to our response times. So at the moment, we are also working on a project in order to provide clients the certificates electronically, which is something positive because we are working on, or we have actually implemented a website where clients can see the certificates on said website, and it's very secure. And if they want to print their documents on the website, they can do so as well. So that's how far we've gotten. Excellent. Thank you, Ruben. Jose Liais, would you like to talk about the progress you've made with Indocal and Inmetro, Jose? Jose, you're muted.
Ok, ahora sí.
Ahora sí.
Nuevamente, gracias, Diego.
Thank you. So when we're talking about automation, I'd say that the first thing we must remember is that the institutes that make NIMET, Ecuador, Colombia, Bolivia, Peru, and now with the approval of Cipm from Venezuela, we've included this country as well. We've been trying to improve the way we work based on our environment. And I agree with Diana as well, because we are now working on various aspects, and we need to think about who it is we're working for. So our automation process is trying to achieve a management system that allows everybody to understand the processes we're focusing on from the moment when the request or the application is sent in. So there are various stages, and each of the institutes have been developing its processes based on its resources, on its conditions. And so there's been a development process at each of the institutes according to what's resources available, as I've mentioned. So these efforts have been implemented in specific manners. And I'd like to talk about INACAL Peru. So we have a system which has implemented each of the stages of the process. For example, from the moment the request is sent in up until the moment the certificate, the calibration certificate, is issued. So the institutes have systems that allow them to address the request via the web, and that's something that all institutes are doing. So in our case in particular, we weren't happy with having a system that was too basic. We wanted to go further. And I think this is something that the private institutes had been doing for a long time. And what we wanted to do was have an online system, a 24/7 system. So we wanted for it to be possible to have people send in a request and for them to be able to receive a response immediately. We wanted to avoid any delays. So, for example, we have about 8,000 calibrations per year, and we wanted it to be automated. That's the process, because we wanted to avoid delays. So we now have a platform via our webpage, and we wanted for people to be able to select the service on the webpage, select the date, when they wanted the process to be carried out, and we wanted for them to receive the quote immediately so that they could decide whether they accept it or not and make the payment immediately. So now this can be done. So what we do after people file their request online, select the date and make the payment so that they can continue with the process digitally. So this level of automation, as was mentioned before, reduces transcription errors, reduces times, and also improves the way we work through the automation. So many institutes are doing this, and we have also automated another aspect, because the information is sent directly to the computer at various levels. So I think this has been very common in our region. So we're all participating in this project we have with the P and the SIM, with the support of the PTB. So if there are any questions, please go ahead. Thank you very much. Thank you, Jose. Thank you for your contribution. And now we're going back to Diana, because I know that you're working on an application through an automated portal for providing services to the client. Could you talk to us about this? Yes, Diego. So I was saying before, we were talking about the portas. So when we proposed developing the portas, as Jose was saying, we wanted to integrate many aspects. So we wanted to focus on the user, on the beneficiary. So the design of Portas is basically for the client. So we wanted to transition in order to benefit the client. And well, Olman Ramos and Fabio Lopez, they're the ones who worked on this, because they are very, very active within the groups. And so when they thought about this, and when we worked on this, we wanted to automate the data. And that's the data coming from the laboratory activities without there being a human intervention, because we wanted to become more efficient, but we also wanted to do something additional. We wanted to, since we're designing the digital certificates, we wanted to be able to integrate them into this platform and for all of this to be included in the cloud. And why? Because, I mean, we almost never do anything that isn't interconnected. We wanted to be able to work in real time. We wanted to be able to provide responses in real time, provide data in real time. And we wanted to move on to an additional step, which was to comply with FAIR principles. That was to be able to have data mining, because, I mean, there's so many data. We'll have over 7,000 certificates annually, and we have clients, companies, with which we interact. And so, I mean, the laboratory has been developing new services in terms of technology. So the companies, for example, are requiring new services. So we've had to implement these services, and we're also been removing other services which aren't needed anymore. So what we wanted to do with Fortis is integrate all of the operations and the calibration and testing services we wanted to include as well. And we wanted to include all of the LCM services as well and use this information to take decisions. So basically do data mining science data. So was to be able to have predictive methods that would allow us to take decisions at a very perspective level, and to have the LCM at the forefront of the industry, so as to not stay behind and then have the industry tell us what we had to do, have the industry saying, okay, we need this, we need that. So we wanted to be able to integrate all of the information, and the most important aspect was that we wanted to have the Fortis in the cloud, and have the cloud allow us to integrate the information, have trustworthy data, and to have a system that would allow us to download data in real time and comply with FAIR principles. So that would be the most important aspect, and I'm available if you have any questions during a Q&A session. Thank you. Thank you, Diana. So now we'll move on to Daniel. So he's working with an automated service portal for the client and in a process automation system. Could you tell us a little bit about that? Yes, I'm going to share my screen to show you a little bit of what this is about. Can you see my screen? Yes, I can. So these principles refer to requests, forms that include quality information, emails, calculations. So now, a few years back, we developed an interactive portal, which is quite simple to use, and basically the client can manage the requests, and they manage automated email notifications, and this information is available on our website. Here we have the software, which is connected with the link. So we receive the request once it's sent to the laboratory, and this is all linked to the equipment that's connected or interconnected with a virtual network. And that's where we collect all of the information generated from the equipment, which allows us to collect the data from the computer. It allows us to carry out the calculations, and it leads us to developing the report automatically. And it contains a digital signature, and then it sends the LIMS report to the client so as to be able to carry out the whole cycle. And this was developed within a project in which we've been participating. So all of these raw data, which was calculated, can be used as a raw material for the digital certificate formats, which can be compatible with the machines. So this all guarantees the legitimacy of the data, and that's something we've been working on. So over the past few years, the laboratory has developed various projects for automating the calibrations. Some imply not just the digitalization, but they also imply carrying out the calibrations through software. And this has all been developed internally. And in some cases, it involves mechanical automation, and it involves the hours the metrologists carry out their work. So for this, for example, we were saying that we have a software for collecting data, and we collect and treat the data. We have also had the determination of the calculation of the specific data, and the robotization of the blocks and pattern data. So these last few cases were presented in meetings and digital transformation groups of the Cipm. Now, when it comes to block comparisons, we have worked through various processes during a period of 2 years. So we have carried out measurements in manual form in the past, and these represented these involved many man-hours with the technicians. However, we developed a software in order to reduce the man-hours required. We worked with the technicians in order to do this, and this led to the automation of these processes. We calculated the results, and we managed to reduce the amount of hours needed. In the year 2020, we carried out the mechanical automation of the process, and we also established what aspects were necessary in order to carry out the tests and do these tasks using this process. Now, under the framework of the CABREC process, we are moving on to the last stage to develop this process so as to carry out the calibration process using the LIMS system in order to carry out the process so as to reach the final stage, which is the issuance of the PDF document. So I've got the link here of a YouTube video so that you can see the full process. Thank you very much. And I apologize for the translation, but I could barely understand what he was saying due to his poor sound. So are there any other questions? So these MLAs work for the client using web applications. So this is the path that the MLAs chose, which we have to support. So perfect. Thank you very much. And we will continue and move on to the next topic. So we know that digitalization of information is part of the automation of the MLA processes. So now one of the responses to this paradigm change is, something that is quite important, as various participants were saying, and this is so that we can insert technology into these processes. So the Metrology Institutes support the industry, and we know that this will be an interesting tool in the immediate future. That's what we've been talking about today. And for that reason, the Metrology Institutes of the Cipm have been contributing in order to be able to issue these certificates. So now I've understood that various entities have been quite involved in these processes. So could you talk about the progress made, Victor? So Victor isn't available. Jose Dajes, do you think you could talk about the DCC or in your region? Yes, thank you. So if we think about Sasha's presentation at the first level, at all of the Institute, which are members of the Intimate, we're using the PDF documents, which are digital certificates, basically. However, the progress made by the various institutes is quite different. However, I believe that they're all delivering PDF certificates with electronic signatures, which which provides a higher level of security. But we're also clear on the fact that depending on who the client is, we have to prepare ourselves in order to make sure that these certificates can be read by a machine, or, well, even if we don't think about these certificates being read by machines, we need to think about the fact that these certificates should include certain types of information and should avoid transcriptions, because that's what some of them are still doing. I'm thinking about a Metrology Institute. I mean, why not think about having certificates that should be inserted into a specific system? I think that would be quite helpful if we were to start thinking about that, because I mean, I don't think that we have a high demand for a digital calibration certificate that can be used in such a manner, because there's a high number of clients with machines that are expecting these sets of certificates, at least in those countries that make up the anti-med. Well, I don't think that this is an urgent need, but I think we are going to reach a moment where these certificates should be able to be read in this form. So we are participating in this project with digital calibration certificates so as to be able to move on to this type of format. But as I've said, we need to think about the needs of our clients who don't have this level of automation.
At this point in time, the SIM and the Cabiret module, and also INEM is participating, and the body from Colombia and Medinacal from Peru. Thank you. This is what I think I had to inform at this point in time. Thank you, Jose. Now, Diana.
Víctor, por favor.
Or Victor, sorry, Victor, please, you. Thank you, Diego. My mic was off. We have been working in this effort that Jose has described correctly. We need to go from PDF certificates with signature to certificates that can be read by machines. In this sense, we are lucky to work with the most important client from Senam, which is a big automotive industry company that's very interested in this kind of system, digital system. And there is a large opportunity to collaborate strategically with this ally, and we are doing that. And from the perspective of the calibration certificates, the digital ones, which it would be the first milestone for digital transformation. And we are working on digital twins, like this is the following level, the next level for digital calibration and certification, because this is a way of managing the information in the value chain and towards the production lines in a comprehensive manner. What does this mean? It means that we're looking for not only the digital certificates and we are read by machines, but that the machines have digital twins so that we can supervise and do remote calibrations and other things. And from that perspective, it is convenient to have a concept that represents a physical object, and we consider that this is the second milestone in the route for the 4.0 industry. In Senam, we are developing digital twin managers aligned with an architecture that 4.0 industry has. And the experimental system is an environment that supports the integration of administration of physical objects and other administrators that act as virtual objects. So regardless of the path that we need to go, long path that we need to go through for digital certificates. In parallel, we need to work in what we think could be the second milestone, that would be the digital twins. Of course, we need to work in lab automation, in the cloud, and all the elements that are somehow going to be linked to the disruptive technologies that Hugo Gasca spoke about, that are already in the industry and that are being implemented already. And that will be the natural link between what is done in metrology and what is done in the industry. Of course, the path is very long, but we are committed to work on this. Thank you, Diego. Thank you, Victor. Now, Diana, please. I will continue to speak about what Jose Dages mentioned about digital certificates. All the laboratories, we all have digital certificates signed by humans, PDFs signed by humans, and they're available. However, we wanted to make available specifically, and this with relation to orienting the digital certificates to a sector that's vulnerable, which is legal metrology. We want digital certification with an XML format in civil market languages, and this is a language that's accepted, and it allows us to integrate the numeric curves to the certification, also determining the authenticity of the certificate, because we could change or falsify, and this could put at risk commercial processes, environmental security, and legitimate objectives. So we want to focus on how we can go from the PDF that can be vulnerable, you know that this is vulnerable in information technology, and go to XML, that allows us to have that key where we can know only the person or the entity that produces a certificate can open the file, and they can share it with the security that it's authentic. So, and we would take care of this process, which is very sensitive, where we see it as a vital process for legal metrology in the context of, because LSM is in a process of international cooperation with the Korean government, and then they're going to do a master plan of legal metrology, and we're going to have an internet site for the user with digital certificates, where mainly we want to work on legal metrology, because it's a vital process for us. Thank you for your attention. Excellent, Diana, thank you for your contribution. It's important for the certificates to be accepted outside country and offering other technologies. Do you have any other contributions related to digital twins and the cloud?
Sí, Rubén, por favor.
Yes, Ruben, please. I wanted to ask or add something. A little while ago, Jose spoke about the need. This is a good point for countries like ours. As I said, we are young, relatively young. The concept of metrology is not completely installed in the country, and our first challenge is for metrology to be accepted in our country. And we haven't developed 3.0 technology, and we're in 4.0. So we have a double challenge in countries like ours to migrate to higher levels. We need to have the will and resources. We don't have that currently, because all of this is done with resources. We need investments for carrying out these transformations. So in the case of Indogal, the idea has been in a natural way, and we have done this in fields where the demand has been growing, because we can justify the investment, and this is what we do. And We have done this with the will of the technicians from our institution. So there is a lot of resistance towards the outside. There's a political resistance. So in parallel to this progress that we need to implement, we cannot deny the existence of this natural resistance that we have in young institutions. They are beginning, and the topic of metrology doesn't look that important for this community. So this is something that I wanted to introduce and to say, because our institutes, I know that there are other institutes with similar characteristics in the region. Thank you very much, Ruben. Excellent. Do you have any other comments? Yes, Jose, something that Diana mentioned, and I agree with her, with the need to to fulfill a requirement from the user. The PDFs have electronic signatures that people want to prove, and based on these phone consultations or emails, we can at least, we have an experience that has been useful. We developed a browser for certificates. The user can corroborate with a number of certificates in a database. So we published the calibration certificates. We published the first page with the information different to legal metrology. There we have the experience from a couple of years about a cloud, and in ACAL we published all these certificates. So our experience with the cloud is that there's more than 16 million verified instruments that are done by secondary laboratories that are authorized, and they publish their results or certificates. And something that mentioned Diana that could be useful, the development of a software for online software. So developing or using this software, and the results go directly to the cloud. So the results are issued online, and they're published and shared in this cloud. And for this, each scale has a QR code, and you scan it, and it takes you to the certificate. So this is something that we could do, and we could share this experience with other institutes from the region. Thank you. Excellent, Jose. Diana, would you like to make a comment? Yes, I would like to thank Jose, because currently we have integrated the cloud, and we verify with a QR, but at an internal level. We haven't done it outside like them, because they have an experience with the verifying units, and I'm going to be integrating after this session. I will be speaking with Jose to see how they can help us with an example, because if other laboratories or other NMIs have done it, I'm not going to get too creative if you already have a valid experience, and we can use a valid experience from others. So I think we need to share them. So I'm going to speak about this and the challenges. And I think one of the challenges is this, to know what other NMIs are doing and being able to exchange valuable experiences to see how we can make progress in block, because it's an inter-American metrology system. Thank you, Diana. And we are going to speak about this now. This is the last topic is going to be the challenges at the short and medium term. And please, Diana, if you want to continue with the topic, or Victor, or if you want to mention about the cooperation from the Cipm, you can do it too. Yes, thank you. I would like to speak briefly about this. Probably from the NRC, this was commented. A very important challenge is precisely knowing the needs of the consumers. I think we are all consumers in this, and we're trying to solve the needs of the consumers. But they emphasize here in the NRC, they emphasize that we need champions for a digital transformation. And the term or the concept of a champion is that in all levels we need our specialists' opinions, and we need commitments towards this. We know there's many limitations, from equipment for digital activities, from lack of staff. We could make a really long list of difficulties. But the important thing is to find the champions that can start with this initiative of digital transformation. And not in Noramet, not in SIM, but in the whole world. Thank you. Excellent, Victor. Thank you very much. Jose, would you like to, would you like to share your opinion about the possibility of cooperating and the challenges that your region has and your NMI? Yes, Diego, thank you. I agree with Victor. The experience, I have some years in metrology and working in SIN, and we have the possibility of saving a lot of time sharing information. And what Diana said, if we have solved this, we don't need to invent things anymore. We need to cooperate. So I agree with that. So we will have difficulties in every institute because of government for each one of the things that we're living. It could be the war, it could be the crisis. That's our everyday situation. But facing these difficulties, the possibility is for regional cooperation to find this help that each one of us needs to develop these topics. And I think we are going to be more successful if we do it like this. The rest is the effort, the dedication, the resources that each one of the institutes has and their possibilities. Thank you, Jose. Diana, do you want to share something? Yes, Diego, thank you. I'm going to refer specifically to 7 challenges that the region has. I am clear about them, and I know my panel colleagues also have them because we have shared many experiences and we understand each other. The challenges that Jose said, we all have them: funding, technical competencies, weaknesses from the political point of view, and technical topics. But I want to focus on one topic that's vital. I would like to start with a phrase. Software is eating the world. What does this mean? Everything is automated through software, and we are going towards that. And what I want to say is that either the software enables, disables, or allows, or doesn't allow us to do something. So we need to see how else, as an NMI, have the challenge of being able to interact with other organizations in a safe manner. Currently in Costa Rica, and I think this is international news, we are being attacked by an organizations and our Ministry of the Interior. Our software got hijacked by those cyber criminals. I don't know how to call them, but so we were attacked, and this generated we stopped with the continuity with our services, our national services, and this could happen with metrology. It's going to be based on software, and we need to take care of it. We need to find tools to protect it. And why? Because there's very smart people on the other side. We have experience, we are technicians, but there's others trying to destabilize these systems. So a challenge is how to protect these systems and softwares. How do we protect them from these vulnerabilities, and how can we have a continuity in the service? The NMIs are for productive sectors and economic sectors, free trade agreements. So if we lose all the calibration processes, we cannot provide traceability to anyone through software. So imagine the risks that we have if we need to be clear about risks and vulnerabilities. related to this, and we should have tools for cybersecurity, which is vital for digital transformation. And we've seen this with other colleagues with the integrity of information and authenticity. How can we reach authenticity and give security to the sectors that relate to NMIs? Another one of the challenges that's important is the speed of the changes in the industry. The industry is changing very fast. We need the NMIs to go from the traditional technologies to expedite methods like Scrum, Agile, and others that will allow us to answer quickly. I know that as metrologists, we need time to structure these processes, but we do need to change to an agile and dynamic thinking to have dynamic projects. So this is a challenge that we should have in Cipm, agile projects that will allow us to make diagnosis, and we should have a respective method to analyze the movements of the industry. We have the war, we have hyperinflation, we have the change. The war is going to generate change, and we're going to go from fossil fuels to electric vehicles or alternative fuels. This is going to change our way of moving and transporting ourselves. And metrology is going to have to be there because we spoke that it is difficult to sell metrology. I think this is another challenge that as metrologists and as technicians we could have on how to sell metrology. Now, we are vital in a digital transformation process. Without us, digital transformation doesn't exist. Why? Because we give confidence, we back this. So there has to be security. And in the end, we can say that we are associated to competitivity, and the crises that we are facing are making pressure on us to increase the level of conformity, just like the industry is doing. It's another topic that's important is to develop a metrological industry that's interconnected in the region. And what does this mean? Getting to know the capabilities of the whole region, but in a manner that is accessible for everybody, so we can see what's happening in Peru, Costa Rica, and so that we can see the work of our colleagues. And we have designated persons that have developed activities that are very important, like the laboratory of ISE for times and frequencies and optic figures. And this topic is, and you could research more about this when we have the infrastructure. The discussion that Jose and I started, if you have done this, why don't we interact for generating an interregional project? It doesn't have to be the same region. It could be, there could be several regions, and we can make a solution that can work for everybody, because if the ones with the least capacities can grow and the ones with more capacities can support us, we are going to grow. And what we're looking is the benefit for persons. We're looking the welfare of people, not that's the purpose of our job. So these are challenges that are there, that are vital, and also the technical competencies. We have digital breaches that are very large. I don't know how they're computer engineers, and we only have one, and you have several ones in other institutions. We only have one, Fabio, and we need to replicate this so that each laboratory can have experts in metrology and the persons that are experts in computers and have both capabilities. And the ones I know are the ones that are here, but they're very few. But it's very difficult to explain to computer persons metrology and vice versa. So there's a learning curve, and there's a topic of technical competence. And I don't know if my colleagues would like to add something, and this would be my contribution. Thank you, Diana. Daniel, can you hear me? Yes, please. I wanted to add to what Diana said. And we all know from the news about the security and information, and we need good practices, and we know we need ISO 27001, and we need help for detecting problems, like what Diana mentioned. The system is based on virtualizing networks, the services and the job posts in the laboratories, and this allows centralized management that will allow us to update this. We have firewalls, which are protection barriers to determine who can go to who can access the services. So we would have passwords for clients so that they can access the services, and they can also access the reports that have an electronic signature, which are PDFs. But we can do this in other areas. And for example, we have networks for laboratory equipment and offices and all the traffic between them. And we have to monitor the internet to seek or to look for potential accesses that are risky. So it's important also to have backups systems for the information and restructuring reports from the backups. So this would allow us to restructure the analysis. Another topic that's important, and this has been mentioned, so I don't want to be redundant, but working in cooperation projects, it's a very good scheme. It's of much benefit, and have common databases and exchange information between the INMs and the training of our technicians, and to level them with other institutions. So it's a resource that we need to use, and it's an excellent platform for formalizing and organizing projects. And this is a strong engine for development. Thank you. Thank you, Daniel. Ruben, do you have some words? Yes, I would like to add that I identify myself with my colleagues. We have similar challenges, and there's also a challenge on how to retain the staff that is prepared, because many times when they're prepared, they become more interesting for the industry. So sometimes they get hired by other institutions or companies. So this is a problem for our institutes. So this part of what strategy to implement to avoid this or to reduce this risk to the minimum. This is a challenge that we have, and we should take into consideration. Excellent, Ruben. The floor is open for questions and comments. We have time for one question. Nobody. No. Oh, well, it has been an interesting discussion, and I'm sure it has covered the expectations from the participants. I would like to thank the panelists, and I will give the floor to Germán. Thank you very much, Diego Copa, and our panelists. It was an excellent discussion table. I am sure it has been very useful for all the representatives that are here in this session. To finalize this event, we will have the closing words from Javier Arias. He studied electromechanical engineering in the Technological University of Panama. Then he concluded his career as an electrician engineer in the North Carolina University in Charlotte, where he also studied mathematics. He also has a master's degree in logistics and international trade from the ULA Sex University, and from 2011 he has been general director of the National Metrology Center for Panama, CINAMEP, for promoting metrological infrastructure and quality for the country. And he is also a project coordinator of CIM, and he is a part of the board of Cipm. So I would ask the participants who are here to activate their cameras so that we can take a picture. So welcome, Javier Arias. It's an honor to have you here for the closing words for this event. Thank you very much, Germán, and thank you everybody here, more than 150 persons this morning in representation of the Cipm Council.
I would like to say a few closing words on behalf of Cipm and on behalf of everybody else. So we've had, as I was saying, over 150 people connected. So this work we are carrying out is, for future development on digital transformation. So now, very quickly, I would like to say that what our chair, Claire Sandry, said this morning is in order to further develop our region regarding digital transformation. Hector and Sasha also added to this from the organizational point of view, not just on behalf of Cipm, but from the regional point of view. So Hector spoke about the Cipm and about how it's worked in regards to digital transformation and from the point of view of the international system. And Sasha also spoke about the OILM, and he also spoke about so the fact that we will need the quality infrastructure in the digital era. So basically, he's saying that it's not that the digital infrastructure is going to disappear. We're going to need it, in fact. And he also said that we're going to need quality infrastructure that must be prepared to work with smart standards, smart products, and smart standards. And this is also going to require a joint effort amongst the various standardization, accreditation, metrology bodies, and it's also going to need conformity assessment standards. Hugo spoke about what we've been doing within Cipm from 2017 and up until now, and he also spoke about what we'll have to be doing in the future up until 2030, and they spoke about what we've been doing since 2014 as well. And this is also going to give us some information about what we'll be doing regarding the Cipm strategic plan. So it gives us an idea of what we're doing all together. And this last speech given by beautiful Diana, and what Victor, Jose, Ruben, and Daniel are doing, who are being led by Diego, in fact. And I think they've all given us a very interesting speech on how Cipm is integrated in order to lead this industry through digital transformation, because all NMIs in the region are working together, and they've spoken about what they're developing through these regional projects, where we're all working with the support of the IDB and PTB. And I think that what Jose said right at the beginning and that Daniel added to, because they were basically saying that despite the fact that this region, our clients, laboratories, and users are not completely automated, which then leads to the fact that this transformation has not fully been achieved. This change is still important, and it requires us to change immediately. And it also requires us to do this through joint projects, as Diana was saying, where we'll exchange experiences so as to benefit everybody without forgetting about the trustworthiness of data. now that they're necessary for digital transformation. So thank you very much on behalf of the Council of the Inter-American Metrology System. I would also like to thank all participants. I'd like to thank Herman for moderating this meeting, and just everybody here for these 2.5 hours. Without anything else to say, thank you, Herman. Thank you for all of the work you've done, and I'd like to congratulate everybody today on metrology, on the Global Metrology Day. So thank you, Javier, for your words. I would also like to thank the interpreters, and I'd like to ask everybody to turn on their cameras so as to take a few screenshots of this event. Okay, Claudia, Francisco is going to take the screenshot. So I've seen that everybody has turned on their cameras. So let us know when you're ready to take the screenshots, and we'll then close this event on the World Metrology Day. So I'm going to go ahead and start now. 1, 2, 3. So I'm going to do this 4 more times. So just give me a moment because there are several of us connected. So next one, 1, 2, 3. Next one, 1, 2, 3.
Dos más.
2 more.
1,
1, 2, 3. And the last one. While Francisco takes the last photograph, I would like to mention to everybody here from Carimed, represented by Ruben, congratulations, because we are representing the Black Heritage Month, which is the Black Heritage Month in Spanish. So congratulations. 1, 2, 3. Last one.
Francisco, muchísimas gracias. Y a todos,
Francisco, thank you very much. And thank you very much for your participation in the World Metrology Day event. So we'll see you in future events, and have a great rest of the day. Goodbye.
Gracias a todos los que organizaron también las transmisiones.
Thank you to all of those who helped us organize the Facebook transmissions and the YouTube transmissions.
Gracias a todos.
Bye, bye. Bendiciones a todos. Bye.
Bye. Gracias. Bye bye.